Welcome, everybody. There is a famous running debate for some time now. Everywhere I go to talk and give presentation, I always get the same question. What's better, SQL or NoSQL? Relational model or schemaless? This is a complicated answer to give, right? So to help me today to see more clearly on this topic, I have the honor to receive these three famous guests that I'm presenting to you right now. So we have Morgan Torker. Morgan is the former product manager for the MySQL server, where he was then responsible of the optimizer, meaning a lot of SQL, but he has also responsible of the new schemaless functionality with the new JSON data type and the X protocol. Morgan is currently a maintainer of Vitesse. I also have the chance to have Marcus, the SQL Renaissance ambassador, Marcus Winnen. As such, Marcus' mission is to make developers aware of the evolution of the SQL in the 21st century. He is also the author of the book SQL Performance Explained that has been published in 5 languages, and you can read it online free of charge. You can also find much of his work on modernsql.com. Marcus is available as a trainer, speaker, and consultant for all companies and developers interested in SQL. And my last guest is Bill Carwin. Bill has many years of experience as a database developer, consultant, and trainer. He published a popular book, yes, another author, SQL Anti-Patterns, Avoiding the Pitfall of Database Programming. Bill is known as the SQL Bible, or at least this is how we called him internally when we were colleagues. Bill has answered thousands of questions on many online platforms, giving him a unique perspective of SQL mistakes that most commonly cause problems. So let's start the debate. And I want to remind people that this debate is a genuine conversation about technology. This is not a war between products, right? So my first question for Morgan. Morgan, as MySQL product manager for the server, meaning, like I said earlier, also for the optimizer, you were present when we also moved into the NoSQL direction. Why do you think NoSQL and schemaless is now a thing?
Yeah, thank you for the question, Fred, and thank you for having me. So I think maybe originally there were a couple of motivations. One was scalability of the database system, and the other was rapid time to market. So you could prototype an application, and then you could have it running with much less time. And I think over time, it's really just shifted to the second of those three. That seems to be the majority of the motivations. You don't have to design your schema in advance. You don't have to know the intricacies of SQL, and maybe we'll chat more about how hard or how easy that is. You can just get started really quickly, and then basically pay later rather than pay upfront. That was the motivation, I think, for me as we were designing some of this functionality.
Oh, thank you. So, and what do you think about this, Marcus? Do you think NoSQL and schemaless, like Morgan says, makes things faster?
Yeah, well, as Morgan said, pay later. So it certainly can save some time up front when you get the prototype up and running. But on the long run, yeah, well, you have to pay it sooner or later. That's pretty much the point. The argument from SQL perspective is not actually whether we have a schema or not, because you always have a database schema. It's just a question how it is managed. On the one hand, you can ask your database to manage it for you, and on the other hand, you can take care of it on your own in the application. But in some way, you have to manage the schema. And as we know, over time, things become a little bit more complex than when you start a startup on a green field. And the longer you run that, the more important it is to manage these things. And there it is a tremendous help if you have a centralized system that is the authority for how the schema looks like. And the way SQL as a language, SQL is just a programming language. The way SQL looks at it is just, it has optional schema management tools. You can use them, but you don't have to. You can have a JSON column if you want to. You don't need to put any constraints on that. You can put in whatever you like. That's also fine for SQL. But you have the option to have some schema management and to have it centrally managed and enforced and also documented. So I think that's how SQL looks at it. You can start with just JSON, that's fine. But on the long run, you would probably like to have some management tools. And this is what SQL is offering.
Okay, thank you. And you, Bill, do you have anything to add about this argument of Morgan telling that it makes things faster?
I think I agree that it does make things faster to start with, but you end up doing more work in the long run. And in addition to what Marcus pointed out, I also see cases where people store their data in a schemaless fashion, for example, in JSON structures. But then some weeks later or months later, they change their mind about how they want the JSON structure to be in the database. And by that time, they already have months of worth of data stored in there. And now they have to rearrange how the data is stored. And they have a dilemma. They either need to go back and rewrite all of the data that they had collected so far into their new idea of the structure, or they have to have code in their application that can recognize both the old and the new generation, if you will, of how their data is formatted. And as time goes on, that just compounds because you end up having more and more decisions about changing the format of the data. And it makes your application code, which is really what is enforcing the virtual schema in your mind in the data, the application code needs to be updated continually.
Yeah, thank you. Yeah, so that goes for, it's a very nice bridge for my second question, right? This is true now that object-oriented programming is the most spread practice, as you know, but you also know that as a DBA, I am personally almost allergic to all these tools that are ORMs, right? That and which I was trying to avoid as much as possible. But maybe then this is the reason why there is this mismatch between application and when people wants to have this design, right? Or because normally when you say, okay, schemaless, it's schemaless. I know that more and more people tries to avoid schema in their schemaless. This is maybe for later. But what do you think, Morgan, about this this way to try to map the object inside the database without mapping it, in fact, without the use of these ORMs?
Yeah, I think there's definitely, it's one of the traditional arguments. There's this object-oriented impedance mismatch, where you have to kind of map things to the relational model to be able to work with the database. And I think traditionally it kind of came from the perspective that the database serves many applications, so to have this abstraction was useful. But as you move into service-oriented architecture, sometimes the database does serve one application. And I think when you can have things sort of closer to the native type that the application uses. And I also don't like the word schemaless, so I'll kind of clarify that now. I think it's more application managed schema than it is schemaless. And if the data just does serve one application, it is beneficial to just have it defined in the application, because then you don't have two records of what the data definition should look like. So yeah, I mean, I do certainly see that argument that there is this mismatch as you move into relational. There's a little bit of confusion in the terms, right, between what is SQL and what is relational, but I'll kind of like murky those waters there, and maybe someone else can clarify more on those details. Looking towards Marcus, who I know will have opinions here.
Okay, thank you. So, and you, Bill, so do you agree with Morgan on that?
The whole question of object relational mapping, I've struggled with this myself over many years, because by adding more code in between the application and the database, it's bound to introduce overhead and some complexity, as you need to understand how the ORM works as well as how the data works. Yeah. So what I look at it as is a convenience tool for trying to map data into your application objects. but I often see there's a missing piece in there when it comes to resolving that object relational mapping. A relational database stores sets of data, whereas object-oriented applications think of things in terms of collections of data, collections of discrete objects, and the objects in that collection have behavior. Whereas in a relational database, the set itself has behavior. And that's something that I see missing from virtually every ORM package that I've ever come across, because they're all developed by object-oriented minded people.
So anything to add on that, Marcus?
Yeah, quite a lot, I guess.
Okay.
So starting with that term relational. I try to avoid that term whenever possible, because it's pretty much overloaded in the meantime. So there was an original definition of what relational means, and SQL actually is not following that original definition anymore. So personally, I prefer to talk in terms of SQL databases rather than relational databases. Even though technically SQL is just following a different definition of relational, it's just confusing people. So I prefer to stick on the terminology SQL rather than relational. And one fun fact when we talk about ORMs and object-oriented programming is when object-oriented programming became hyped somewhere in the 90s mostly, or became popular somewhere in the 90s, the object-oriented database, or the object relational database, was actually a big thing there. And at that time, it was actually added to the SQL programming language. So in the year 99, there was a new standard of the SQL programming language, and that was covering storing entire objects in single columns. It was done. The object relational database is actually there. And you see how this kind of contradicts the definition of relational as you might have heard it maybe 20 years ago. So that's also the reason why I prefer to say SQL, because it's really beyond the original definition of relational. And then, yeah, coming to ORM tools. Yeah. I think ORM tools are super handy to get the simple tasks that are frequently done more quickly done when implementing some software. And this is mostly focused at CRUD operations, where you work on a row by row basis, or object by object, if you prefer that term. And you just fetch one object, you update one object, and all of that. And that's a quite common task. That's no question. And ORM tools are a great help to get these tasks done quickly. But that's not the full story. In every single application, you also have non-trivial tasks. And they are, of course, not so frequent like those simple CRUD operations. And what I see most people missing is that they think when they use an ORM tool, they have to use it for every single database interaction. And that's just wrong. Most ORM tools are designed to use side by side with plain SQL at the same time. So you can use the ORM framework and the functionality to get the frequent simple operations done quickly, but you can still use the power of SQL to get the not so common tasks, but the more complex tasks also done quickly. So it's really just a question of choose the right tool for every database interaction. And one thing for last is that I often see that people think using an ORM or not is an application scoped decision, like, okay, for this application, we use an ORM. But that's not true. It's for every single database interaction. You can choose whether to use an ORM technology for that or to use an SQL. And this is really something people need to get into their heads, that this is not an either or question. We can have the best of both worlds.
Yeah. No, thank you. But for my experience, what I saw is that when people or developers are using or forced to use an ORM at the beginning, right? They don't know anymore how to not use the ORM. So that may be also something complicated, and that makes me go to the third question I have for you guys. Is that if we stay there, is that therefore, if we can bypass that, the way of using the ORM, or without the ORM, with the direct access to the SQL database, This is why maybe NoSQL and the CRUD operations with all this API connection or the connectors maybe are better for all this new or this modern application made by this developer, because they are thinking like that, and they are not thinking anymore like we did years ago or decades ago. So what's your opinion on that, Morgan?
Yeah, I think you're right, Fred. I do think that the connectors, if we just exclude SQL for a minute, do show some things that are more relevant to modern applications. You know, being able to set read or write concerns as you insert data, rather than just have transactions. You know, not every row in the database has the same value. Some data can be regenerated. You know, having sort of more finite control over some of those semantics, I think is very useful. And I think it would be nice, you know, if the relational database connectors did have more of those semantics that sort of closely follow how modern apps are developed.
Thank you. So, Marcus, do you think so that this modern application and this kind of CRUD operation API can get, let's say, can stop using SQL, or do you think it's they are still is it still needed somehow?
Yeah. Well, just to add to what Morgan just said, right concern and so on. It's true that SQL has pretty strong opinions when it comes to consistency. And I think that the SQL language needs to be a little bit more flexible in that area. So just
follower reads, approximation functions, stuff like that.
Yeah, some products do have these approximative functions, but that's not official part of SQL. You know, I think there should be there's something missing there, no question. And then coming to the question API, is it good enough for everything? I think if you just look at the past 10 years, maybe when NoSQL became a thing, all those NoSQL vendors started with their slick API, which was mostly just CRUD operations, what people need, what is easy to understand. And now, just look at them. Almost every successful NoSQL system has added some kind of QL language, sometimes even aiming for SQL support. So yeah, of course, APIs and CRUD operations, they are very common and they need to be optimized and they need to be available, no question. But that's not the end of the story. If you just look at what all those NoSQL vendors did, I think the message is clear. Having a powerful query language or transformation language, as I prefer to say, is absolutely necessary.
Thank you. So, and you, Bill, do you think the same?
I very much agree. What I come to think about when this topic comes up is the law of leaky abstractions. A leaky abstraction is a layer of supposed simplicity in software that works in many cases, but eventually you come across a case that the abstraction does not handle well. And then you have to be forced to understand what the underlying implementation is that the abstraction is trying to simplify. And a great example is what Marcus brought up about writing complex SQL logic that cannot be done in a CRUD model. But there are many other cases of that as well. And I think the APIs that simplify things, the ORMs, all of these types of mechanisms that try to simplify, eventually, if you want to use your database optimally, or you want to do something that the API doesn't handle well, you say, okay, now I have to learn a different layer and I have to go deeper. And that's more or less inevitable in any non-trivial system.
Thank you. But so do you think that when they came with this idea of CRUD operation and API and all the NoSQL story, it's maybe also to avoid to avoid the developer to make the kind of mistakes that as DBA you saw with SQL and relational model, that your book is full of example, right? Or the answer you got, maybe this is the reason, right? No?
Exactly. The mistakes that I see over and over again are often about attempts to optimize. And what I like to say is you cannot optimize everything at the same time. Every form of optimization chooses one path of query type to optimize, and it does so at the expense of others. So others get worse as you optimize one path. The mistakes that I see are when people don't understand which of the types of queries they want to optimize for. So that you can use, for example, denormalization in an SQL database and store comma-separated lists. You can have a string with a list of items in it that are comma-separated. And that would optimize when you want to collect that whole list and return it back to the application quite well. That would be a good optimization for that one. But it makes it much harder to search for a specific item in that list. It makes it difficult to index or to optimize that. NoSQL is the same way. You can organize your document-oriented data in a fashion that collects nested objects or nested arrays within JSON, or you could store it in key value format over many, many entries in a key value store. But they all need to be chosen to serve specific application needs, specific application queries. And you can't choose which one is going to be optimal for your application until you know the queries that you are going to be running in that application.
Thank you. So, and yeah, no, that makes sense for me. And so you, Marcus, do you agree with your SQL colleague here?
Yeah, mostly. I found it quite funny that you said, okay, a simple API avoids all those mistakes we have with SQL. I'd like to put it rather that way, to say, well, with great power comes great responsibility. And if you have a more powerful tool at hand, you can, of course, make bigger mistakes.
Yeah.
Like it's not just about databases. Let's think about tools, hardware, like a chainsaw. Okay, with a chainsaw, you can cut a lot of wood quickly, more quickly than you could do it manually. But if you have a more powerful tool, you can also make more damage. So the argument to use simple tools to avoid the damage, pretty much, yeah, it's an interesting idea for me.
You also can't make a straight cut with a chainsaw.
Well, if you are experienced, maybe. I don't know. So it's the question, can you cope with that tool you're having? If you are able to use the tool properly, then it's not causing all these mistakes. Of course, you need some education. For more powerful tools, you need more education to get it done correctly. I think that's the most important point here. It's an education topic, basically.
Do you agree?
SQL looks so, one last sentence. SQL, it looks so innocent because it's you can read it. You can understand it when you read it. But there is much more semantic behind it than it looks on the first sight. So most people are
I want to come back to that after. Thank you. So Morgan, do you think so that with this API and stuff, more power give you more responsibility?
I agree with part of Marcus's point, which is that you can't really site check SQL. It's a declarative language and you can't tell if it's efficient. But I think as you scale applications and you scale teams, it's hard to scale that knowledge base, right? One of the hardest things is not scaling the application, it's scaling the team. And so if a language is that expressive and allows you to have that much freedom, seeing many of the large MySQL deployments, they all have middleware between MySQL and the database that basically stonets and terminates poorly running queries and prevents bad things from executing. And I think if these guys can't solve the problem, I don't think that you can either. I think that's a very hard challenge. I don't think that NoSQL doesn't have this problem, but everyone wants to move fast. Everyone wants to have rapid time to market. Some of this is just going to be inherent. So we need to sort of say what features can we offer to be able to protect against that. That's more where I would think that the need is. You can't stop it. It's a freight train.
Yeah, thank you. Yeah, but to be honest, I use the NoSQL also, and and I like it. I think it's very nice. But like you said earlier, it's very, you can, let's say, make stuff happen very quickly and prototype very rapidly. But as rapid you can prototype stuff is so quick that you reach the same limitation quickly. I mean, for example, and it's the same for NoSQL, but it was the same for ORM. When I see people, if you read the code, when they use ORM at a certain point, when they are able to do it, you can see that almost at the end, maybe they get a user from the ORM and all the rest is SQL they are writing. So I think personally that MySQL is still very powerful for that. And I would like to hear from Marcus what he thinks about. So SQL, it's still there, right? And you can you reach limitation very quickly with the NoSQL or with this CRUD operation. Do you agree on that?
Yeah, absolutely. So saying that MySQL is powerful might be an understatement. As I mentioned before, most NoSQL systems start to provide some query language sooner or later. The interesting thing about SQL is that it's now, well, it's old, which many people think it's a bad thing. But on the other hand, it's also rock solid, and it has a still ongoing development. So right now, the SQL standard is, for example, extended by graph query processing, like that you can have a native graph query in there. Things like that are happening. SQL is adjusting to market needs. That's no question. And it's extremely powerful. I study it now for the SQL standard. I study it now intensively for 5 years, and I'm not even 10% through, I guess. So it's really powerful. What I think, what the really important idea about what SQL is, it's not a query language. It's a transformation language. And as I think Bill mentioned before, when you store data persistently in some format, it will be hard to change that data later on, no matter in which format you store it. If you just collect JSON documents and just store them, and after you have collected a petabyte, it will be hard to change the structure of what you have already stored. Persistent data is hard to change. So the idea for SQL was, let's design the persistent data model in such a way that it doesn't need to be changed often, so that we normalize it, not in the technical term like all these normalization levels, just in the natural term of the language, make it normal for the data. And then whenever we are doing some processing with that data, let's transform it on the fly into some format which is more convenient for that data access we are doing right now. And SQL is exactly this transformation language, actually. So the idea is to keep the data model rather static, because the data you're processing, the true nature, the form of the data you're processing, hardly ever changes. But what changes every day? The requirements, what we want to do with the data. This changes very often. So the idea is to keep the one thing static and the other one just dynamically transformed on the fly. This is SQL. SQL is the transformation language between something which is hard to change on disk and something we read right now for one particular processing step.
Thank you. So, Bill, do you agree with that?
Yes, and I have some things to say about it. That's a very powerful concept to talk about data and frame it in terms of a canonical kind of data that you can then transform using queries into whatever you need it to do today in your application. And of course, requirements change from time to time. So we would like to have the data stored in as flexible a way as possible. And the concepts that we learn in relational database design do support that. The normal forms, and I'm speaking of the formal definition of normal forms, they have a special purpose. It's not to make things more high performance. It's to make things resistant to data anomalies. That is, inconsistencies between the data as you store it. You don't want to have the author of a book be Stephen King over here, and the author of the same book be Charles Darwin over here. Which one is correct? We don't know. We've lost that information. But in a relational database that has been well designed, it avoids those sorts of anomalies or inconsistencies. Starting from that foundation of the data organization, then having a language that can transform the data from that form into anything your application needs and be flexible enough to change from day to day is very, very powerful. But it depends on having the relational concepts of being able to organize the data and to have a formal method of saying, yes, we have achieved normalized form, therefore we are going to be able to resist the anomalies.
Thank you. So Morgan, do you have something to add on that, or do you have a different opinion here?
I mean, I certainly agree on the premise. By having this abstraction and being able to transform it, it makes sense. I think in practice, though, it comes back to that time to market argument, where I think initially it was intended that you would sit down with a data modeler and you would figure out the schema. But in practice, that doesn't really happen these days. A developer designs a schema and then you launch. And I also think that abstraction helped when you had many applications or many consumers of the data that you could transform in different ways for your application or for your reporting package and so on. But in the way that a lot of applications are designed now, this is just a database that serves the application rather than the application serves the database. And so I think when you flip that on its head, that kind of describes why there's not this investment that happens up front. Everyone does prefer to pay later rather than pay now.
Yeah, thank you. Yeah, so I think the war of, let's say, opposing SQL and NoSQL, it's also, like Marcus said a bit earlier also, it's that people joining that battle, I mean, are limiting what SQL is, right? So as an expert on SQL, Marcus, could you provide us a bit more information? Because as you say, SQL, it's in the 21st century, it's more than a query language. You explained that a bit, but could you give us a bit more information on that?
Mm-hmm. So the first thing is really that schemaless is the buzzword, but from SQL perspective, it's rather that you have non-uniform columns. That was introduced in SQL in 2003 into the international standard of SQL. So there's a standard for SQL, and in 2003 they added documents at that time in XML format. And that was a pretty big step for SQL because previously they were following that strict, rigid idea of the schema to have one data type in one column and that must be uniform across the full table. And that's gone. That's not a thing anymore. In the meanwhile, we have JSON support and some other formats. We have nested tables, arrays, all of that. So that's on the schema side. SQL is now embracing a more flexible kind of relational model, if you want to say so. So where each data item can be anything, like Chris Date likes to say. And the other part is really this transformation step, where SQL provides you all those tools for these transformations. And if we look, for example, at MySQL, when 8.0 came out, we've got some of those really, really powerful tools like window functions and recursive queries. So we can now basically write queries that in one query deliver us all the data we need to get one job done. That's the idea. Ideally, every application would just ask one question to the SQL database, get all the data it needs to do its job in one step. Like with recursive queries, we can now fetch an entire hierarchy in one go and just get row by row one item of a tree, for example. That's now possible. Previously, we had to go ping pong between the application and the database. And these are just a few examples, but SQL in the 21st century has really evolved beyond the relational model on the model side as well as on the operation side. Because when you think about the transformations, the traditional transformations are like joins or union. We still have them, but we also have like window functions and recursions, and we have time travel queries and. So it broke free from the relational cage as we know it. And this is, I think, SQL in the 21st century. And this is now living up to the promise to be the glue between the persistent data model, which is rather static, and those flexibly, rapidly changing demands we have in the processing side.
Thank you. So, Bill, do you join Marcus on that? And also, as you know, SQL, the standard SQL, also includes plenty of JSON functions, right?
Yeah, I've been actually developing with some of those recently. I have a application I'm working on currently that stores records of data in a pretty normalized fashion, but then to present it in the result to an API endpoint, I use JSON functions to wrap it and create a quite complex aggregate object out of many rows of data that are stored in the database, using JSON array ag and JSON object ag and so on with group bys. I ended up creating a query that was a full screen of code with 4 levels or 5 levels deep of nested subqueries in it to produce all the result in JSON from normalized database in one go. It takes somebody of my level of experience to be able to author that kind of a query, but it's very powerful. The complexity has to go somewhere. All these different technologies and techniques, you're only pushing the complexity onto one side or the other. It's either in the data or the model, or it's in the queries, or it's in the application code. And you can't get away from the complexity that is required for your application. It's got to be implemented somewhere. So we have to just choose which level we want to implement it in.
Thank you. So Morgan, something to add on that?
Yeah, no, I think Bill's point makes sense. You do have to push the complexity somewhere. And I think for developers, they may feel more comfortable pushing that into their application. So it's in a language that it's kind of their native language. But it's quite easy to point out cases where that might not perform well. So it's not like that's a silver bullet.
Okay. So thank you a lot for your insight, guys, and for this debate, for these arguments. And as we can see, there is valid points on both, and this is why we're gonna not solve it today. And this is why this traditional relational database or SQL database, like Marcus likes to call them, are focusing more and more on JSON document and JSON document store, like MySQL does. And for example, we have JSON values recently added and more, and we have CRUD operation and all that kind of stuff. But like you said earlier also, that the NoSQL vendors are also implementing queries, languages like SQL or not. So it all depends what are the needs. So, but I think we had a lot of information here for the people following us and listening to this. I think it was very, very positive. So thank you very much.